Okay, beta. So, any more doubts, queries coming in your mind? Please share. So we will clarify them and then we will proceed ahead. Okay. So all clear, beta? Ready to go ahead?
Yes, sir.
Okay. Okay. So beta, next topic which I am picking up is stars suitable for sight. This topic, as I told you, is basically intended for the December batch. For January and February batch, I will be covering up this topic again in the next month. So March to April, when we have our next module running. So I will be covering up this topic again because इस topic में nautical almanac का usage है. There are a couple of concepts. One is the concept of magnitude, stellar magnitude. दूसरा इसमें concept है twilight का. So I will cover those concepts now also. But even if you don't understand some parts of this topic, that is for January and February batch, it's perfectly in order as we will be covering them again. Huh? Okay. Second thing is, beta, this topic. Okay, let me open up the presentation, then we will continue. Okay, so beta, this is the topic for today. So, stars suitable for observation. So this topic basically covers up question number 7 of our paper. Most of the time, the question number 7, which comes in our MMD paper, is based on this concept of stars suitable for sight or stars suitable for observation. Now, there are a couple of things which I want to share with you before we proceed into this topic. One, this topic requires a basic understanding of stellar magnitude and the concept of twilight. So we will cover both these concepts briefly when we go into this topic. And second thing is that this topic is not suitably covered in the book. So there is an exercise which is given, a small exercise which is given in the PRACNAV book. But the questions which are coming in the paper are more advanced than what is given in that exercise. So for this topic, I will be sending you a separate assignment. There will be some questions. I will give you the answers also, so you will be able to solve and check your solution. The method, how these questions are to be solved, since it is not suitably covered in the book, I will send you this method also with the assignment, so that you have a ready reference, a ready reckoner whenever you are doing this particular question. Now, I have divided this question into 5 different types. So there can be 5 little variation, though the basic question remains the same, but there could be 5 variations which can be put in the question. The question can be presented to you in a little different format. So we will do these formats or types one by one. The first type is what you can see on the screen. This says which star will be within a certain R angle of the observer's meridian at a given time. So as I told you, total 5 variations are there, and this is the first type or first variation which we are going to do now. Okay, so before we go into this type, let me explain a little bit about the stellar magnitude. Now, what is the stellar magnitude? All the celestial bodies which we see in the sky, we see them because of light coming from that body to our eyes. Now, the amount of light which comes to us from a certain body, it differs, it varies from body to body. The most brightest body in the sky is the sun. Now, after sun, the next brightest object which we see in the sky, the celestial object, is the moon. After moon come different stars and planets. So this brightness of the celestial body is depicted by a scale which we know as stellar magnitude scale. So if you want to refer to the brightness of a particular star, you can refer to it by using this stellar magnitude scale. Now, one important thing about this stellar magnitude scale is that this scale is inversely proportional to the brightness of a star. Means the more bright a star is, the lesser will be its magnitude. Like you can see the diagram which is there on the right side of the screen, the black color diagram. It gives us the stellar magnitude of the sun as minus 26.8. So sun being the brightest object in the sky, its stellar magnitude is of the minimum value. The second brightest object is the moon. So full moon has a stellar magnitude of minus 12.5. Then comes Venus when it is at its brightest self. The magnitude or the brightness of planet keeps on changing depending upon their location in the solar system. But when Venus is the brightest, its magnitude is minus 4.4. Then comes various stars, Sirius minus 1.5, Alpha Centauri 0, Betelgeuse 0.8, Polaris 2.5, and so on. Now, important milestone ahead is after Polaris, you see naked eye limit. Okay, you can see it in the diagram. Let me pick up a pointer. I will not be able to show it on the black screen, but you can see the naked eye limit here somewhere. This is the naked eye limit, and that naked eye limit is stellar magnitude 6.0. So it basically tells us that the dimmest star, the most faint star which we can see with our naked eye, is of stellar magnitude 6.0. If the brightness reduces a little bit or the magnitude increases more than 6.0, it becomes 6.1, then it goes beyond the limit of our naked eye. We will not be able to see that star with a naked eye. Yes, if you have some special tools, equipment, then you can see that particular star. Like good quality binoculars, you may be able to see stars up to stellar magnitude 10. And the Hubble telescope which we have, Hubble telescope can observe celestial bodies up to a stellar magnitude of 30. That's the capacity of the Hubble telescope. So this is the stellar magnitude scale. Now in these questions, this stellar magnitude scale is used. We make a reference to the stellar magnitude scale because when we find out the stars, they ask us to find out the stars of a particular magnitude. So we have to check their magnitude from the almanac, and we will pick up only the stars which they have specified or referred to falling under that magnitude range. Now, how are different type of stars categorized? Let me show you how the categories of stars is made. Now, all the stars whose magnitude is 1.0 or lower, they will be the most bright star in the sky. We have categorized them under the category of first magnitude star. So if you pick up a star from the almanac and its magnitude is either 1.0 or any value lower than this, it could be 0.9, it could be 0.0, it could be in the negative range also, minus 1.0, minus 2.0. Anything less than 1.0, equal to or less than 1.0 will fall under the category of first magnitude star. Then a star having a magnitude greater than 1.0, that means 1.1 up to 2.0 falls under the category of second magnitude star. And 2.1 to 3.0 falls under the category of third magnitude, and so on. Usually for taking site, whenever we take a star site, we always prefer or recommend first and second magnitude stars because these are the brightest stars which are available in the sky. You can also take a site with third magnitude, fourth or fifth magnitude, but since their brightness is much lesser, practically it is difficult to observe those stars using a sextant. So it is recommended that for taking a site, you pick up, if possible, a first magnitude star only. And in case you have a cloudy sky or not too many stars are visible to you because of any reason, then if a second magnitude star is available to you, then that too can be used. We avoid taking site with stars which are fainter than second magnitude. In these questions also, they will tell us to find out the stars fulfilling a certain criteria, and they will tell us that we need to find out the first magnitude stars falling in this particular criteria. So then we will check their magnitudes, and we know 1.0 or lower, any magnitude of the star will be fitting our answer. So this is the concept of stellar magnitude. The second concept, how do we find the magnitudes of these stars? Now for this, you have to go to the almanac. So if you have a nautical almanac, you can keep it close, you can open it up, and you can go to page number 268 of your almanac. I have the screenshot of that page here also, so I will explain it to you what this table mentions. Now, this table given on page 268 is basically the stars table, and the first thing which it gives is the magnitude of the star. So you can see this number written. First star number is 3.4, the second one is 2.6. This is the magnitude or the stellar magnitude of the star. Then you have the name of the star, like say for example, the first star which is there is Cephei. After this, you go to the next column. It gives you the SHA of the star, sidereal R angle, SHA of the star. You will see the SHA of the star is given for every month. So you have a value for January, February, March, April, May, June. Now this is the left side page of the almanac. If you go to the right side page, you will have the values given for the later 6 months of the year, that is July to December also. Now when you pick up the SHA from this table, you see the value of SHA in degrees is given in the first column. See, for Cephei, you can see the SHA is 5 degrees. And later on in the monthly columns, they only mention the minutes. The reason for this is that the SHA of the star does not change much. If the change happens, usually 99% of the time, the change happens in minutes only. Like you can see for Safei, in the month of January, the SHA was 15.4 minutes. In the month of February, it becomes 15.9 minutes. So we can pick up the degrees from the first column, and we can pick up the minutes from the month in which the site is taken. The same thing happens with declination. You go to the right side in the third portion of the table, you have the declination of the star. The first column under declination gives the value in degrees. It also tells us whether the declination is north or south. And later on, under each month, you have the value of minutes mentioned. Like for Safei, the first star, declination is 77 degrees, 35.7 minutes in January. In February, it becomes 35.6 minutes. Now, one important thing about this table is, if you look on the right-hand side of the table, the right-hand side of the table basically caters to the last 6 months, that is July to December of the year. Now, there sometimes you may find that the name of the star which is given on the right-hand side may differ from the name given on the left side. Okay, so you may have a name mentioned here as Alpha Pegasi, and on the right side, the same star may be mentioned under the name Markip. So why is there a difference? The difference is because the names of the star are given in Latin as well as English. So names given on the left side page are Latin names. Names given on the right side of the page are English names. Now, as far as our examination is concerned, we always use the English names of the stars. So for that purpose, you always pick up the name of the star from the right side page of the table. Whether the month is January or the month is July or December, the name is to be picked up from the right side page of the table. The value of SHA and declination will be picked up from the respective month in which the site is being taken, but the name is always picked up from the right side page of the table. English names are what we use for our examination purpose. Okay, so that's page number 268 of the almanac. Okay, next comes the concept of twilight. So let's first understand what this twilight is. The light which we receive from the sun during the day is known as sunlight. Now, when the sun sets, it does not immediately become dark. The brightness of the sunlight reduces slightly or slowly. As soon as the sun sets, it is not that it immediately becomes pitch dark. When the sun has set, we do not receive any direct light from the sun, but the atmosphere is still illuminated. Now, after sunset, as the sun keeps going down and down from our horizon, we cannot see the sun now. The sun has already set. But as it keeps going down, the light starts to slowly decrease. And it takes some time for it to become pitch dark. Now, this light which we receive from the sun after sunset or in the morning before sunrise is known as twilight. When the sun is there in the sky, we can see the sun. That time, if we receive any light from the sun, it is known as twilight. It is known as sunlight. But when the sun is below our horizon, it will happen before sunrise in the morning, and it will happen after sunset in the evening. Now, in both these cases, when we receive some light from the sun, when it is below our horizon, that is known as twilight. Now, we have observed that this twilight is available to us from the horizon to 18 degrees below the horizon. That means after sunset, when the sun is going down from the horizon, you can say the altitude of the sun is decreasing. It's negative altitude now, -1, -2, -3, -6, so on. We keep on receiving this twilight till the time the sun goes 18 degrees below the horizon. So when the sun is 18 degrees, up to 18 degrees below the horizon, we receive twilight. But when the sun goes beyond 18 degrees, that is more than 18 degrees below the horizon, we stop receiving any light from the sun. So 18 degrees below the horizon is the cutoff, after which we do not receive any twilight. The same thing happens in the morning. In the morning, the sun is slowly coming close to our horizon from the bottom. So the negative altitude of the sun is decreasing. Now, when the sun comes within 18 degrees of our horizon, twilight starts. And as soon as the sunrise occurs, the twilight stops and it converts into sunlight. Now, this twilight period is very important for us, for the navigators. Why it is important is, you see, if you have to take a site. Now, for taking a site, you need to see the horizon as well as the celestial body. Now, when we want to take a star site or a planet site, a star or a planet site, now stars and planets are not visible to us during the day. They are visible to us during the night. Okay. Now, during the night, the horizon is not visible to us. We cannot see the horizon. Horizon is visible during the day. It is only in this period of twilight that both the horizon and the stars are visible to us for this short period of time. So if we want to take a star site or a planet site, we need to use this twilight period. In this twilight period, we will be able to see the horizon and we will be able to see a planet or a star. And for taking site, both of these things should be visible to us. So that is the importance of this twilight period. Now, last thing about twilight is, this 18 degree of twilight is basically split up into three parts. From 18 degrees up to the horizon, this total period is known as astronomical twilight. You can see it here also. The astronomical twilight ranges from 0 degrees to 18 degrees below the horizon. Now, the period from 12 degrees to the horizon is known as nautical twilight. So, horizon to 12 degrees or 12 degrees to horizon is the nautical twilight period. And the period from 6 degrees below the horizon to the horizon is known as civil twilight. So 0 to 6 degrees is civil twilight, 0 to 12 degrees is nautical twilight, and 0 to 18 degrees is astronomical twilight. The same thing happens in the evening. From the horizon till the time the sun goes 6 degrees below the horizon, this is known as civil twilight time. From the horizon, that is from the sunset, to 12 degrees below the horizon, this is known as nautical twilight. And from sunset or from the horizon to 18 degrees below the horizon is astronomical twilight. Now, sometimes people get confused that astronomical twilight is 18 to 12. it is not that way. All the three twilights are measured or counted from the horizon to different angular values. Civil twilight is from the horizon to 6 degrees. Nautical twilight is from the horizon to 12 degrees. Astronomical twilight is from the horizon to 18 degrees below the horizon. In other words, all these three twilights overlap. Between 0 to 6, like say, at the time of sunset, all the three twilights come in at the same time. All the three twilights, they commence at sunset. Civil twilight continues up to 6 degree below. Nautical twilight continues up to 12 degree below the horizon. And astronomical twilight continues up to 18 degrees below the horizon. Similarly, before sunrise, when sun reaches 18 degrees below the horizon, astronomical twilight commences. When sun reaches 12 degrees below the horizon, nautical twilight commences. When sun reaches 6 degrees below the horizon, civil twilight commences. And all three of them end at the time of sunrise. Now, in the almanac, they do not give us the astronomical twilight times because this is not required by us. This is required by astronomers or people who are using these tools or telescopes, powerful telescopes, to observe the sky. Now, we observe the sky with the naked eye. So, for us, out of this total 18-degree period, only a small zone is beneficial or useful to us. Which is the zone which is useful to us? Now, look carefully in the morning. The beneficial zone for a navigator is commencement of nautical twilight, or in other words, when the sun is 12 degrees below the horizon, up to commencement of civil twilight. This zone, when the sun is between 12 degrees to 6 degrees, is important for us. When the sun is more than 12 degrees below the horizon, there is so less light that the horizon is not visible to us at all. So we are not able to take a sight. When the sun comes less than 6 degrees below the horizon, there is so much of light that the stars are not visible to us. So again, it is not useful to us. We cannot take a sight. So for the purpose of sight taking, in the morning, commencement of nautical twilight to commencement of civil twilight is important period for us. And in the evening, you see, ending of civil twilight, when the sun goes 6 degrees below the horizon, to ending of nautical twilight, when the sun is 12 degrees below the horizon. This is the suitable period for us. So, when the sun is between 6 degrees to 12 degrees below the horizon, that is the suitable period for us for taking sights, star and planet sights. Now, both these times, the nautical and civil twilight times, are given to us in the almanac. If you see in the morning time before sunrise, they give us commencement of nautical twilight to commencement of civil twilight time. And in the evening, along with sunset, they give us ending of civil twilight time to ending of the nautical twilight time. An important thing to keep in mind is that in the morning, the twilight times which are given to us are the commencement times or the beginning times. And in the evening, the twilight times which are given to us in the almanac are ending times. So that is important to know. So these are the two concepts which are important for understanding this question, stars suitable for sight. So this covers up twilight as well as stellar magnitude. तो अब बेटा इन दोनों में कोई डाउट अगर आपको आ रहा है, you can share those doubts with me.
तो लेट्स से सन अगर 3 डिग्रीज बिलो द होराइजन है तो उस टाइम पे तीनों ट्वाइलाइट चल रही है मतलब, या सिर्फ तीनों चल रही हैं?
तीनों चल रही हैं।
ओके।
और बेटा एनी अदर डाउट इन दीज टू टॉपिक्स, स्टेलर मैग्नीट्यूड एंड ट्वाइलाइट?
सर ये एल्मेनाक में सर ये एंडिंग का टाइम दे रखा होता सर, सनसेट का जो सिविल का टाइम दे रखा है एंडिंग का टाइम दे रखा है सर सिविल
बेटा में इवनिंग में एंडिंग है और
हाँ।
मॉर्निंग में स्टार्टिंग है।
ओके सर।
ओके, बिकॉज जो मॉर्निंग में एंडिंग होगी वो तो सनराइज के टाइम पे होगी तीनों ट्वाइलाइट की, और इवनिंग में जो स्टार्टिंग होगी वो तो सनसेट पे हो जाएगी।
जो सर अगर जैसे उसमें 0552 मिनट दे रखा है सिविल का सनराइज के उसमें, तो मतलब उस टाइम पे सिविल टॉयलेट स्टार्ट हो रही है।
दैट्स राइट।
ओके सर, और उसके नीचे वाले में दे रखा है 17 डिग्री 17 और 39 मिनट सिविल का, तो मतलब उस टाइम पे एंड हो रही है सिविल टॉयलेट।
दैट्स राइट, एग्जैक्ट।
ओके सर।
ओके, सो शैल वी कंटिन्यू फर्दर बेटा?
यस
आगे
सर।
बेटा कभी भी हाई लेवल अलार्म आएगा तो मुझे बता देना।
अभी तक तो ठीक है सर।
ओके, ऑल राइट। ओके, we have about 20 minutes to go, so we should be able to cover up type 1 problem here. Okay. Okay, so let's go back to the presentation and we see the first type of problem which comes in this question, star suitable for sight. Okay, so beta, we are starting off now with our first type 1 problem in star suitable for sight. Now, as I told you, this question will ask you which stars will be within a certain R angle of the observer's meridian. Now, let's first try to understand what they are asking us. So for this, I will take you to the rational horizon diagram. So let me show you a rational horizon diagram. This is a rational horizon diagram. Now, let's assume that our observer is in the northern hemisphere. If we are in the north hemisphere, then in this diagram, you see the equinoctial would be like this. And this point is known as Q point, where the equinoctial crosses our meridian. And the pole would be somewhere here. So I have taken the observer in the northern hemisphere. And this question, type 1 question, is asking us, find the stars which are within a certain R angle of the observer's meridian. They will give you a R angle in this question. Let us, for example, take the R angle as 20 degrees. So they want us to find the stars which are within 20 degrees of the observer's meridian. So how will we find them? First of all, let's identify the observer meridian. In this diagram, PZQS, this line basically represents the observer's meridian. Now, if you want to have the stars within 20 degrees of this, let me draw this 20 degree angle. This 20-degree angle is measured at the pole. So at the pole, if I go 20 degrees toward the east side and 20 degrees toward the west side, and if I draw the celestial meridians here, ये मैंने एक celestial meridian draw कर दिया है 20 degrees east पे, और ये मैंने दूसरा celestial meridian draw कर दिया है which is 20 degree west of the observer. अब बेटा यहाँ पे मैं stars show करता हूँ. There could be many stars in the sky. So let me mark. There are some stars in the sky. It could be anywhere. So I'm just marking the stars here in the diagram. So in this diagram, beta, you can see many stars. Now they want us to find out which stars are within 20 degree of our angle of the observer meridian. So basically वो चाहते क्या हैं, ये जो रेड जोन बाउंड्री हमने बनाई है, इस रेड जोन बाउंड्री के अंडर कौन कौन से स्टार्स आ रहे हैं. ओके, so let me highlight these with the red color. तो ये मैंने बेटा जो स्टार हमारी बाउंड्री के अंदर आ रहे हैं उन स्टार्स को रेड कलर के साथ हाईलाइट कर दिया है. So these are the stars which we need to find out. This is the meaning of the question. Find the stars which are within a certain R angle of the observer meridian. Okay, अब हम इसे find कैसे करेंगे? Now for finding this, first of all, we will take a imaginary star. ये imaginary star हम कहाँ लेंगे? We will take that imaginary star on our meridian. ये मैंने बेटा एक green color का star बनाया है, green color star which is on our meridian. Okay, let's call this as star X. So let me just write here X. This green color star is star X. So this is the imaginary star which is on our meridian right now. The star which is on our meridian, ऐसे स्टार का जो LHA है, local R angle, any body which is on our meridian, उसका local R angle will always be 0. Because जो local R angle measure होता है, that is measured with reference to the observer's meridian. So if you have a celestial body on our meridian, its LHA would be 0. So अब हम क्या करेंगे बेटा? सबसे पहले तो हम ये जो ग्रीन कलर का स्टार है, इस ग्रीन कलर के स्टार का SHA फाइंड आउट करेंगे. इसका SHA कैसे फाइंड आउट कर सकते हैं? I will tell you. Let's go back to the presentation. Find out the SHA of an imaginary star which is on the observer's meridian. Now, how do we do that? He is talking of the green color star. The SHA of a star on observer meridian can be easily obtained by keeping LHA star equal to 0 or 360. Whichever value you like, you can keep the LHA equal to 0 or 360. Because when the star is on our meridian, this is also known as meridian passage, the LHA of the star is always 0 or 360. Now we know LHA of a star is equal to GHA star plus minus longitude, and we know GHA of a star is equal to GHA Aries plus SHA star. So we apply the longitude plus or minus. Why there is a plus or minus? Depending upon whether the longitude is east or west, we will write a plus or minus here. Longitude east, GHA least. Longitude west, GHA best. So this plus and minus will be decided by the name of the longitude. So we have kept it equal to 0 or 360. Now beta, in these questions, the longitude of the observer is given to you. So you have this longitude known to you. They also give us the time in these questions. So from the time given, we can find out GHA Aries from the almanac. So both these values, when you put in the equation and you take it to the right side, आपको immediately पता चल जाएगा what is the SHA of this particular star. This is the only unknown in the equation. So put the value of longitude, put the value of GHA Aries. Longitude is given to you in the question. GHA Aries can be easily obtained from the almanac against the date and time. And once you put these values, आपके पास ये star का SHA आ जाएगा. So when you have the SHA of this green color star, now let me go back to the diagram. When you have the SHA of this green color star, you can easily find out the SHA of both these red boundaries. आप इस वाले star का, let me draw another star here. Let me take a yellow color now. So आप ये जो येलो स्टार्स मैंने बनाए हैं, ये मैंने दोनों बाउंड्रीज पे बना दिए हैं बेटा. सो इन दोनों येलो स्टार का SHA हम लोग फाइंड आउट कर सकते हैं. कैसे फाइंड आउट कर सकते हैं? वी नो द एंगल विच इज गिवन ऑन टॉप, एंगल P जो हमने बनाया है, दिस इज द गिवन एंगल. इन दिस केस वी हैड टेकन ए एग्जांपल ऑफ 20 डिग्रीज. सो वी नो दिस एंगल इज 20 डिग्रीज. जो भी हमारे ग्रीन स्टार का SHA आया है, उसमें अगर हम 20 डिग्री माइनस कर दें तो हमारे पास इस येलो स्टार का SHA आ जाएगा. और ग्रीन स्टार के SHA में अगर 20 डिग्रीज ऐड कर दें, दैट बिकॉज वी आर गोइंग टूवर्ड्स वेस्ट, तो हमारे पास ये दूसरे वाले येलो स्टार का SHA आ जाएगा. सो ग्रीन स्टार के SHA में आर एंगल की वैल्यू प्लस और माइनस करने से हमें दोनों बाउंड्री वाले स्टार्स का SHA मिल जाएगा. और इन अदर वर्ड्स यू कैन से दोनों रेड कलर की बाउंड्रीज का SHA हमें मिल जाएगा. लेट अस से फॉर एग्जांपल जो ये ग्रीन स्टार है, इसका SHA आ जाता है 100 डिग्रीज. सो व्हेन यू डू 100 प्लस माइनस 20, you get two values. One value is 80, that is 100 minus 20. Other value is 120, that is 100 plus 20. Now you know the SHA of these red boundaries is 80 degrees and 120 degrees. Now it is very easy to find these stars, red color stars. कैसे find out कर सकते हैं? बेटा जो हमारा 268 पेज का टेबल है, that table gives us the list of stars in increasing order of SHA. The list is given in increasing order of SHA. So from 000 degrees to 360 degrees, the SHA of the star is listed in the table. So we can go up to 80 SHA. So let us say this is 80 SHA, and we can start checking all these stars, and we will stop at 120. जितने भी stars इस range के बीच में हमें table में मिलेंगे, those are the stars which will lie between 20 degree R angle of the observer's meridian. Now let me show you the same thing in the presentation. So as I told you, add and subtract the R angle within which stars are to be found. This will give you two values of SHA, like we have just now taken 80 and 120. Take these values as limits of the SHA. These are the limits or boundaries, and check the stars from the table on page 268 of the 1992 almanac. You can see here the stars are listed in increasing order of their SHA. Say Phi is the star with the minimum SHA after 0. Then you have Pegasi, Alpha Pegasi, Beta Pegasi. So the SHA value increasing from 5 to 13 to 14, 15, 19, and so on. Now the table lists the stars in increasing order of SHA. We use the star names given on the right side page of the table, as I told you before, as these page names are English names. The names given on the left side page are the Latin names. And again, remember, stars with magnitude 1.0 or lower fall under the category of first magnitude, and magnitude 1.1 to 2.0 under category of second magnitude, and so on. So usually in the question, they give you the category also. They will tell you find the first magnitude stars lying between a certain R angle of the observer meridian. So you only pick up the stars whose magnitude is 1.0 or lower. Now, sometimes it may happen that in these questions, time may not be mentioned. They may only give you the date and AM, PM, or morning or evening twilight. Now, in that case, if it is morning or AM, you can use nautical twilight starting time, which is given in the almanac. Why we use nautical twilight starting time? Because this is the beginning of the suitable period for taking a sight. So a navigator should be standby at this particular time if he wants to take a star sight. And if they have given you PM or evening twilight, then in that case, you use civil twilight ending time. Why we use civil twilight ending time? Because this is the beginning of the suitable period for taking sight. So a navigator should be ready when the civil twilight ends, because exactly at that moment, your suitable period is starting off and you should be ready to take the sight. So this is type 1 problem. How to find out which stars will be within a certain R angle of the observer's meridian. ओके, तो अब बताओ बेटा, ये समझ में आया?
हाँ जी सर।
अरे SHA में लिमिट्स इंक्लूडेड है, मतलब अगर 40 डिग्री का लिमिट आता है और लेट्स से कोई स्टार का SHA कोइंसिडेंटली 40 डिग्री एग्जैक्टली है तो
इंक्लूड बेटा, प्लीज इंक्लूड इट इन योर आंसर.
ओके सर.
ओके
सर क्वेश्चन में अपने को ये दिया रहेगा जो मेरिडियन पे, जो अपनी मेरिडियन पे जो स्टार है उसका SHA दिया रहेगा?
नहीं बेटा, वो हमें निकालना पड़ेगा.
इसमें क्वेश्चन किस टाइप से पूछा जाएगा सर?
क्वेश्चन कैसे पूछा जाएगा?
यस सर.
ओके, लेट मी शो यू ए क्वेश्चन स्ट्रेट अवे. मैं अभी दिखाई देता हूँ आपको, एक सवाल दिखा देता हूँ. जस्ट गिव मी 1 मिनट. Okay beta, just read out question number 1. So this question number 1 is a type 1 problem. This is how it will be given to you. राइट बेटा, ये समझ में आ रहा है?
हाँ सर, तो इसमें हम फर्स्ट SHA के कौन से स्टार का निकालेंगे जिससे अपने को ये रेंज मिल जाए 45 डिग्री का?
ओके, अब देखो उन्होंने बोला है 45 डिग्री ऑफ आर एंगल. उन्होंने हमें डेट बता दी है 29 नवंबर 1992. हमारा लॉन्जिट्यूड है 9245 ईस्ट. ओके, so let's keep it on the side. Let's open up the PPT and see what does the PPT say. देखो बेटा, लेफ्ट साइड में आप PPT देख रहे हो. They say अब हमें सबसे पहले फाइंड आउट करना है SHA ग्रीन कलर के स्टार का विच इज ऑन द ऑब्जर्वर्स मेरिडियन। ओके, ये कैसे फाइंड आउट करेंगे? व्हेन ए स्टार इज ऑन द मेरिडियन LHA स्टार इज इक्वल टू 0 और 360, राइट। हमारे पास पे LHA 0 होता है बॉडी का, आप उसे 360 भी लिख सकते हो, एनीथिंग विच यू लाइक। नाउ LHA ऑफ द स्टार इज इक्वल टू GHA स्टार प्लस माइनस लॉन्जिट्यूड। GHA star is equal to GHA Aries plus SHA star. Okay, that is the see, GHA of all the stars is not given in the almanac. What is given is GHA Aries. किसी भी स्टार का GHA अगर निकालना हो तो GHA Aries में हम SHA स्टार को ऐड कर देते हैं, हमें उस स्टार का GHA मिल जाता है। तो यू सी हियर, हमें चाहिए GHA Aries की वैल्यू जो हमें मिल जाएगी। 29 नवंबर 1992 को उन्होंने PM बोला है, टाइम उन्होंने नहीं दिया, तो PM पे हम कौन सा टाइम पिकअप करेंगे? आई जस्ट नाउ टोल्ड यू
सर सिविल ट्वाइलाइट का एंडिंग टाइम,
राइट, सिविल ट्वाइलाइट एंडिंग टाइम, इट विल बी गिवन इन द एल्मनैक। तो एट दैट टाइम हम पता करेंगे एल्मनैक से कि GHA एरीज कितना है। तो GHA एरीज की वैल्यू आ गई हमारे पास। Second thing is they have given us the longitude 90 to 45 east, हम longitude को भी यहाँ पे डाल देंगे। Once you put these two values, तो आपके पास SHA star आ जाएगा बेटा।
यस सर।
Okay, and once you have this SHA, this is the SHA of the green star, उसमें हम लोग 45 डिग्री प्लस और माइनस कर देंगे, तो हमारे पास दोनों बाउंड्रीज का SHA आ जाएगा। ओके, तो लेट अस से अगर मेरिडियन वाले स्टार का SHA 100 आया, तो एक SHA हो जाएगा लिमिट में 100 माइनस 45 विच विल बी 55, और दूसरा हो जाएगा 100 प्लस 45 दैट इज 145। तो 55 से 145 की रेंज आ गई। उसी रेंज में हम टेबल में जाके स्टार्स को ढूंढेंगे, और 45 टू 155 तो बहुत सारे स्टार्स होंगे, उनको हमने लिखना शुरू किया तो 10 मिनट तो उनको लिखने में ही लग जाएंगे। सो फॉर दैट सी दे हैव गिवन यू फर्स्ट एंड सेकंड मैग्नीट्यूड स्टार ओनली। तो इसका मतलब है फर्स्ट मैग्नीट्यूड होता है 1.0 और उससे कम, सेकंड मैग्नीट्यूड होता है 2.0 और उससे कम। तो हमें 2.0 और उससे कम मैग्नीट्यूड वाले स्टार को ही अपने आंसर में लिखना है। राइट बेटा?
यस सर, अंडरस्टूड सर।
ओके ओके, तो बेटा इसको हम लोग आज यहीं पे रोकते हैं। मैं ये नोट्स आपको भेज दूंगा। जैसे मैंने आपको बताया क्वेश्चन नंबर 1 जो है दिस इज ए टाइप 1 क्वेश्चन, तो आप इसको प्रैक्टिस कर सकते हो। इन नोट्स में जो मेथड मैंने PPT में बताया है दैट मेथड इज आल्सो मेंशन्ड, so just follow this method and you should be able to solve these questions. बाकी की जो टाइप हैं 2, 3, 4, 5 that we will do tomorrow.
सर एक बार बताएंगे सर हाउ टू फाइंड द मेरिडियन पैसेज ऑफ अ स्टार?
The meridian passage time of a star?
जी सर।
Okay. बेटा वो भी बड़ा आसान है। मेरिडियन पैसेज के टाइम पे you are from which batch बेटा?
सर जनवरी।
जनवरी बैच, ओके। तो हमारे पास टाइम निकालना बहुत आसान है बेटा। यू कीप द LHA ऑफ ए बॉडी इक्वल टू 360। जब आप LHA इक्वल टू 360 रखोगे, अभी जैसे हमने किया, हमारे पास GHA की वैल्यू आ जाएगी। इफ इट इज ए स्टार तो GHA एरीज आ जाएगा, इफ इट इज ए प्लेनेट तो GHA प्लेनेट आ जाएगा, इफ इट इज सन और मून तो GHA सन और मून का आ जाएगा। जो भी GHA की वैल्यू आपको वहां पे मिलती है, you have to enter into the almanac and see कि वो GHA कितने टाइम पे हो रहा है। Now the only thing here is normally almanac में हम एंटर करते हैं टाइम के साथ और GHA को ढूंढते हैं। अब हमने GHA के साथ एंटर करना है और रिवर्स वर्किंग करनी है कि कितना टाइम है।
हाँ सर, ये जैसे क्वेश्चन नंबर 2 में था ना, उसमें फाइंड द PR एंड एग्जैक्ट मेरिडियन पैसेज जो आपने भेजे थे,
राइट
क्वेश्चन, तो उसमें जैसे GHA एरिस प्लस SHA स्टार प्लस लॉन्गिट्यूड ईस्ट इज इक्वल टू 360, तो वो
Right.
उसमें SHA हमने उस स्टार का ले लिया, वो थोड़ा समझ नहीं आया सर, मतलब क्योंकि वो SHA कैसे, मतलब समझ नहीं आया मुझे।
बेटा वहां तो स्टार दे रखा है ना कि कौन सा स्टार है।
हाँ जी सर, तो ये
वहाँ
SHA कैसे पता चला कि ये मेरिडियन पैसेज का ही SHA है? मतलब ये SHA मेरिडियन पैसेज का ही होता है क्या सर?
बेटा SHA किसी भी स्टार का फिक्स होता है, चाहे वो मेरिडियन पे हो चाहे वो कहीं भी हो।
ओके
हर एक स्टार का SHA फिक्स्ड है। ओके, जैसे सेफई है, सेफई का SHA फिक्स्ड है 5 डिग्री 15 मिनट जो भी है, 5 डिग्री 15 मिनट अगर उसका SHA है, इट इज फिक्स्ड, वो चेंज नहीं होता है। स्टार मेरिडियन पे आ जाए तो भी उतना ही है, स्टार मेरिडियन से चला जाए तो भी उतना ही, क्योंकि SHA का मेरिडियन के साथ कोई लेना देना नहीं है। SHA इज बेस्ड ऑन एरीज। एरीज भी सेलेस्टियल स्फीयर में फिक्स है, स्टार भी सेलेस्टियल स्फीयर में फिक्स है, तो दोनों में जो डिफरेंस है वो सेम ही रहता है।
ओके सर, तो ये फिर कैसे हुआ कि ये मेरिडियन पैसेज ही हुआ फिर? क्योंकि SHA तो फिक्स है ना, मतलब
SHA तो फिक्स है, बिल्कुल सही है।
तो GHA एरीज प्लस HSA स्टार प्लस लॉन्गिट्यूड इज इक्वल टू 360।
राइट,
तो ये एक बार मेरे को सर थोड़ा कंफ्यूजन सी हो गई, कैसे मतलब?
कंफ्यूजन ये हो रही है कि ये इक्वल टू 360 कैसे आया।
जी सर।
ओके बेटा, जो मरपास होता है, मरपास का क्या मीनिंग है? बॉडी इज ऑन अवर मेरिडियन, राइट? बॉडी इज ऑन अवर मेरिडियन।
यस सर।
ओके, अब जो बेटा SHA होता है, लोकल आर एंगल, लोकल आर एंगल, ये क्या होता है? इट इज द एंगल एट द पोल, मेरिडियन ऑफ द ऑब्जर्वर एंड मेरिडियन ऑफ द बॉडी।
यस सर।
अगर बॉडी आपकी मेरिडियन पे है तो LHA कितना हुआ?
या फिर 000 होगा या फिर 360 होगा सर।
ले सकते हैं, 0 और 360 दोनों इंटरचेंजेबल है।
ओके सर।
एग्जैक्टली, तो आंसर आ गया बेटा कि हमने इसको 360 के इक्वल क्यों रखा, क्योंकि उन्होंने हमें बताया था कि मरपास है स्टार का, उसका टाइम निकालना है, इसलिए रखा बेटा।
ओके ओके सर, ये 360 इसलिए रखा। ओके सर, ठीक है। जी सर, जी सर। और अगर मेरिडियन पैसेज की जगह कुछ और दिया होता तो 360 नहीं ले सकते थे हम? 360 और 00 तभी लेंगे जब मेरिडियन पैसेज पे होगा।
एग्जैक्टली।
ओके सर,
ओके,
थैंक यू सर।
ठीक है बेटा, ओके। हाँ,
सिविल टॉयलेट टाइम्स होते हैं, ये LMT टाइम्स होते हैं?
यस, दीज आर LMT टाइम्स।
ओके सर, ओके ओके।
दीज आर ऑल LMT टाइम्स। इन्हें हमें LIT लगा के GMT में कन्वर्ट करना पड़ता है।
ठीक है सर।
ओके बेटा, बाकी के डाउट कल के सेशन में ले लें, बिकॉज नहीं तो तुम्हारा लंच जल्दी जल्दी करना पड़ेगा।
यस सर।
ओके,
ओके
ठीक
सर।
है बेटा, ओके ओके
ओके सर, बाय बाय।
बाय बाय।